5 for geometry, the showing how we're going to prove triangle congruence through the side, 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 or SSS triangle congruence postulate. Again, there's not really a proof that's done as much as a demonstration showing that that we need all three sides to be congruent. Getting back to this whole idea, right? So let's go ahead and take a triangle here. And proving congruence between two triangles. We talked about with demonstrating congruence that we could talk about all 6 parts, right? The 3 sides and the 3 angles being congruent between 2 triangles, right? And all those parts would be corresponding to one another. Something for us to consider here is another way to do this. Now, we've already worked with the side, angle, side congruence, correct? And that's how we started here, was right with side, angle, side. That angle, of course, had to be included, had to be sandwiched in between the 2 sides. And what happens there is that we actually kind of get a 2-for-1 in that construction. When we're constructing this angle right here, what winds up happening is that to connect this side right here and know whatever this width is, whatever we're doing there to do that, right? Using the compass, when spreading that width, we're actually going to achieve, not only are we going to achieve that congruent angle, we're going to actually achieve that third congruent side, right, simultaneously. So we actually kind of get a 2-for-1. This guy, this third side winds up being congruent as really like an outcome of that side, angle, side congruence construction. So it's really a 2-for-1. When we have side, 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 angle, side, we really technically at the same time simultaneously have side, side, side. So let's go ahead and do a proof. And I'm going to kind of go over again how we kind of inventory when we're doing these proofs to make sure that we have the established amount of information that we need, right? Because we don't need to give 6 congruent statements. We really actually only need 3. So let's go ahead and mark the things that are congruent in this diagram. And what's given to us in this proof is that we have KL, it's going to be a short proof, right? KL congruent to LN, and KM congruent to MN, okay? And then, of course, what we're going to prove are these 2 triangles here. Triangle KLM congruent to triangle NLM. All right. So, of course, we can do the first step on our own, right? Left side statements, right side reasons, and we're just going to restate these guys, KL, that's given KL and LN, as well as KM congruent to MN, and that's, of course, our given step, right? Now, think about this. What's usually the minimum number of steps we're going to need? And we found so far it's really 3 that we've seen, okay? Also, how many parts do we need to establish congruent? And we've learned that it's only just 3. For side, angle, side, it was 2 sides and 1 angle, but the angle specifically had to be included, otherwise it wasn't sufficient proof. Here we only have 2 sides, right? But the thing is we would need to say it's going to be these 2 angles which are included, and we have nothing that really is going to kind of take us there. Instead, what we can actually say is going to be congruent is the following. We could say that LM, of course, is going to be congruent to itself, right? Reflexively. The reflexive property. So this guy right here is our third side. So we're done. We actually have what we need. 1, 2, 3 things for all sides. So we have now used our new postulate to prove that triangles KLM and NLM are indeed congruent. And that is through, remember, our reason is going to be a 3-lettered answer, typically. I'm about to give you an exception to that, which really isn't. It's a 2-lettered answer that really means this, right? It's really that it's going to be SSS, or side, side, side. So anytime we're saying triangles are congruent, it has to be, for us so far right now, it's side, angle, side, or side, side, side. Okay, I'm going to give you guys, remember we had the vaunted angle, side, side postulate, right? That was kind of like the potty mouth postulate. We don't want to write that in all capitals, right? That should feel awkward to you on a math test, or really any test. To So you're going to take two triangles here that are clearly right triangles and call this guy ABC and the next guy DEF. And these two triangles, the funny thing is that these actually are congruent, but it doesn't really look like we have a sufficient amount of information to establish that, right? Because we don't have side, 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 and we don't have side, angle, side. Even though we have two sides and an angle, this angle is not included. Technically, we have angle, side, side. That's problematic. Except for, here's our exclusion. We're using a right triangle. So our right triangle is going to use what's referred to as the, I got a little autocorrect on there. It's referred to as the hypotenuse leg theorem, or the HL for short, because we don't like to write too much, okay? This is our lone exclusion that looks just like angle, side, side, okay? So here's what our exclusion really does. It's the reason it works this way is this is due to what's called the Pythagorean converse, which we've discussed very, very briefly, which in this case is going to establish that really what's happening here is that BC, that third side of the first triangle, is congruent to FE, the third side of that second triangle. And it happens in right triangles because of the following. If triangle ABC is a right triangle, and it is, then what that means is the Pythagorean theorem applies. Okay, so let's take a look. Pythagorean theorem, if you recall, is a squared plus b squared is equal to c squared. Now, what on God's green earth does that mean? Well, let's think about how we define A and B. A and B are what are called legs, and C is the hypotenuse. What differentiates the hypotenuse from the other two sides in that right triangle is that this hypotenuse, which in this case is AB or DE, right, is that it is opposite that right angle, okay? So let's go ahead and make sure we make note of that. All right, so works like this. Let's just take one of the legs, hypotenuse leg, right? One of the legs is 4, and let's make our hypotenuse 5. So what that means with regard to the Pythagorean theorem, for the record, let's go back here. We established A and C are congruent. I'm sorry, AC is congruent to DF. So if AC is 4, then DF has to be 4, right? And then AB, if that's 5, then if it's congruent to DE, it means DE has to be 5. So this is how it's going to show that CB and FE have to be the same, right? Because it's going to be A squared plus, of course, 4 squared is equal to 5 squared. A squared plus, in this case, 16. It's going to be equal to 25, right? A squared is going to be equal to 9, so A is equal to 3. It doesn't really even matter what we solve for A. It's just that we know that if CB, BC squared, right, is going to be equal to 4 squared plus 5 squared, which is, right, because those guys are congruent, or FE squared is going to be equal to 4 squared plus 5 squared. These guys are equal to the same thing, so they wind up being equal to each other. B squared equaling FE squared, and of course you can take a square root of both sides, leaving us simply that BC is congruent to FE. Okay, so we just substitute and we know that those guys have to be the same. So really, do you know what this is? It's not really an exclusion to angle side side. Gentlemen, this is really actually an extension of side, side, side. That's really what hypotenuse leg is doing because of the Pythagorean converse. Okay? So we can use hypotenuse leg. It actually saves us a step here because we could actually use the Pythagorean converse as reasoning. Let's take a look at one more proof here today. And we're going to have PQRS with these two opposites being congruent. So given here that PQ is going to be congruent to RS. Also, that angles Q and S are right angles. Okay, and what we're going to prove is that triangle RSP is congruent to triangle PQR. All right. So, again, statements and reasons. And we're going to restate what we have here. And we're going to try to make this look like our, three things here. Angle Q and S are right. And for us to do any of these proofs, again, we have to have three sets of congruent statements, and we have one. Okay? So let's get our second one here. And of course, I think we're going to see two things that are going to be hopefully a little bit obvious. One of them, of course, is this guy right here, the reflexive side. So PR, of course, is going to be congruent to itself, right? Kind of silly reflexive property. Now, we should know that angles Q and S are going to be congruent. Now, sometimes this is so obvious because they're both said that they're right, but people haven't been explicit enough yet when doing the proof to give us this third necessary congruent statement. And the reason we can say that is, again, kind of stating the obvious, which is reasoning we've used before, and that all right angles are congruent, okay? And now we're actually home. We're home. We can actually do this guy now. We can actually say that RSP is congruent to PQR. And it's because we have this instance of those right triangles, right? That gives us the hypotenuse leg theorem that we can employ here. We could do this a little bit differently too, right? But because we have Q and S congruent, we've established those three things. We could be done here. The other thing we could actually do, if we redid this proof, is we could actually do a step here after step 3, effectively showing that, could you say that PS is congruent to QR? And the answer is yes. And the way we could do it, your reasoning, of course, would be the Pythagorean converse. Once you're there, now you have your three sets of sides, and then your answer in the end would actually be hypotenuse leg. It would actually be side, side, side. So that's actually, you can see, this doing hypotenuse leg saves us a step. The other proof we're talking about would have been a 5-step proof, and this one was just 4. Go ahead and get started on your homework. It's posted on Canvas, and good luck.